Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pagard. We're on the last video for Unit 9, that is Video 6, Solving Rational Equations. And you will be learning how to solve rational equations. That's our learning target. Looks like there are 5 steps. I don't really focus on the 5 steps, but it kind of lays out what we're going to be doing. First step is to solve the related equation. I kind of do these 2 steps at the same time because we talked about undefined values, and that's what the second step is. Set your denominator equal to 0 and solve this value is excluded from the domain, means it's undefined at that point. But solving it, talking about something like 1 over x plus 3 over 2x is greater than or equal to, we'll say 1/2. We're going to solve the related equation, so we got to get a common denominator. So looking at your denominators for step 2, what are the excluded values? Before we even solve it, I guess. X and 2x, if you set them equal to 0, I'll just set 2x equal to 0 here because our denominator cannot equal 0. Dividing both sides by 2, x equaling 0, basically that means x cannot equal 0. That's one of our excluded values. And we're going to use that later when we come up with our solution. Then we'd actually solve this equation by finding our least common denominator. And in that case, we have a 2 here and a 2 here, so I'm going to need a 2 for the number part of it. I have 1x here and I have 1x here, so I'm going to need an x to the first power, not an x squared. So 2x squared would be my least common denominator. I'd get a least common denominator for all the fractions, and from there solve it, finding a solution. Step 3 is this. From the step 1 and 2, solving the equation, getting a solution, and then step 2 was finding the constraints or the values that make your answer undefined. Anyway, it says use the values from step 1 and 2 to create a number line, draw a vertical line at these values to separate the number line into intervals. So eventually you're going to have a number line here. I know one of my excluded values is 0. I don't know what the solution to this is. Let's just say x equals 3 was my solution for whatever reason. 1, 2, 3, right there. Now we split the number line up into 3 pieces with our solution and our excluded value. Okay? So being it's an inequality here, talking about inequalities, your solution could be in one of 3 intervals. You get the first interval here where everything is x is less than 0. We have the last interval over here where x is greater than 3. And everything in between the 2 here, that's 0 is less than x and x is less than 3. So there's 2 parts to this, and it's usually one or the other. It's between the 2, and it's considered an and statement because you can write it together, and this would be my solution. Or it's one of these 2. And I'm going to show you how we check it in a little bit here. Your answer might be x is less than 0 or x is greater than 3. So it's the middle one in between them, or it's these 2 put together with an or statement. So it's kind of like compound inequalities, working with those again. Now, the other answer might be it's not this interval or this interval, but it's just this one, x is greater than 3. That doesn't happen too often, but it does happen once in a while. That's why you have to do step 4. Okay? Step 4 is test a sample value in each interval to determine, I got this all mixed up, to determine if the values in that interval satisfy the inequality. Well, this one was x is less than 0, this interval right here. Okay? So we might pick like -1 and plug it into the original equation to see if it's solution or not, so to see if our answers are from that interval. And then once you've tested each interval, you use the test results to write a solution to the inequality. And we're going to go over all this stuff again. I just wanted to kind of go through a little bit and let you know kind of what we're getting at here with these steps. And steps 1 and 2 I kind of do in the same step anyway. because I'm going to find my undefined values first, and then I'm going to find my least common denominator and solve the related inequality. So, here's our steps. We talked about the steps, steps 1, 2, 3, 4, and 5. And we're going to use a number line here in a little bit. Put it right there. Okay. Step 1 was to solve, and step 2 is to find the undefined value. So I'm going to do step 2 right here. And we're going to find the undefined values. There's only one variable in the denominator, and it's just b. When is b equal to 0? Well, when b is equal to 0, you don't even have to solve it. So what I'm saying is, this is 0, a value of 0 would make these fractions undefined, therefore it wouldn't be a solution for this inequality. So that's step 1, or step 2, but step 1 is actually solving this bad boy. So we need a common denominator, least common denominator. Our least common denominator, this is 7 over 1 now, it's just going to be b. So solving this, I'm going to get a common denominator first. I'm going to multiply top and bottom of this 7 over 1 times b over b, and end up with 7b over b minus 2 over b is less than 5 over b. All my denominators are the same, so I can go ahead and drop those just like an equation and solve the numerators as my inequality. So it's 7b minus 2 is less than 5. So adding 2 to both sides, I get 7b is less than 7. So I get, dividing both sides by 7, b is less than 1. So my solution is b is less than 1. Actually, we're going to solve it like an equation, I guess. So b is equal to 1. So how does this work with our number line? You take your constraint, what b cannot equal, and you take your solution from the equation, b equals 1, and you graph those on the number line here. It doesn't really matter how you write them in. There's 0, and I'll say 1 is right here. So it splits my number line up into 3 different intervals. And your solution is going to be from 1 or more of these intervals. So the first thing I would do is pick a number from each interval. I'm going to pick -1. I'm going to test that out for this first interval zone. In between 0 and 1, I'd pick probably 0.5 or 1/2. And over here, I'm just going to pick 2. I'm going to plug those in to my original inequality and see if it makes it true or false. If it makes it true, all the numbers in that interval are a solution. If it makes it false, the numbers in that interval are not a solution. So for interval 1 here, -1, plugging that in to see if it is a solution or not. So we just did step 3 right here. This is step 3, setting up the number line with the solution, which is 1, and our constraint or undefined value, which is 0. Step 4 is actually testing the values. So plugging in -1. 7 minus 2 over -1 is less than 5 over -1. And I get 7, well, this is plus a positive. 7 plus 2 is less than -5. So we got 9 is less than -5. Is 9 less than -5? No, this is false. So this area, this region right here, does not work. None of those values are going to be a solution. I'm going to plug in 0.5 now, or 1/2. So I got 7 minus 2 divided by 0.5. It's less than 5 divided by 0.5. I'm going to get 7 minus 2 divided by 0.5 is 4. You can do it on your calculator if you're not sure. 5 divided by 0.5 is 10. So this is 3 is less than 10. This is true. 3 is less than 10. So what does that mean? Everything between 0 and 1 are a solution. So I'm going to write 0 here, 1 here, and I'm going to put b in the middle. It is less than 1, and 0 is less than b, so it's between 0 and 1. That's part of my solution. Now I test this last zone to see if that is the solution where I plug in 2. I'm going to get 7 minus 2 over 2 is less than 5 over 2. So this is 7 minus 1 is less than, well, it'd be 2.5, 2.5, whatever. 6 is less than 2.5. 6 less than 2.5, no, this is false. So this region right here, greater than 1, is not a solution. So all my solutions are between 0 and 1. Okay? It is less than, so I would leave my 2 circles open. If it was less than or equal to, I would probably color this circle in, but it cannot equal 1, so I wouldn't color that circle in. Anyway, both circles are open. Here's my solution right here. 0 is less than b, and b is less than 1. That's our first one, kind of using all the steps. And step 5 was to choose your solution based on plugging in your test points, and we plugged in all these test points, and we found the only area that works is between 0 and 1. So that's why we write our answer like this. Okay, let's move on to the next one. We got our little number line over here. Step 1 is to solve the inequalities in the equation, and step 2 is to find any constraints, any values of a that would make this undefined. So I'm going to do that first. I got 4a and 8a. Basically, if I just take 8a and set equals 0 and solve, I'm going to get a equals 0. So a cannot equal 0. This would make my value, or the value of the fractions, undefined. If you did the same thing with 4a, you're going to get 0 again. Divide both sides by 4, you get 0. So there's just one constraint, basically. And we're going to use that on our number line over here in a minute. That was step 2. I did it first. Sorry. Step 1 is to solve this now. So I'm going to need the least common denominator. I have a 4, an 8, and a 2 in my denominators just for the numbers themselves. 8 covers all of them. 4 divides into 8, 2 divides into 8, and 8 divides into 8. There's 1a here and 1a here, so I'm going to need just an 8 of the first. So my least common denominator is 8a. So 1 over 4a, I'm going to have to multiply this by 2 over 2. That would give me my 8a in the denominator. Plus 5 over 8a, well, it's already 8a, equals, we're just going to solve the equation part of it, 1/2. And I'm going to have to multiply, first of all, by 4 over 4, and then also an a, so 4a over 4a. So my new equation becomes 2 all over 8a plus 5 all over 8a equals 4a all over 8a. So, have a common denominator, so I basically solve the equation that's in the numerator, so that's 2 plus 5 equals 4a. So 7 equals 4a. Dividing both sides by 4, I get a equals, you could say 1 3/4. I'm just going to say 1.75. Same thing, so it's really close to 2. 1.75. So looking at my number line up here, first things first, I'll put 0 right here. We'll say this is 2, this is 1, so 1.75 is right about right there. Really doesn't matter where you put it, but I put it there. So we have all my answers in the first interval, which is basically everything that's less than 0. We got everything in between 0 and 1.75, and our last interval is everything greater than 1.75. So just splitting it up and then testing each zone. I have this interval, I have the middle interval, and I have the last interval there. A checkpoint I could use for this first interval, I'll say is -1. In between 0 and 1.75, I'm going to use 1 as a checkpoint. And I could use 2 or 3, it really doesn't matter. I'll go with 2 because it's greater than 1.75. So -1, 1, and 2 are the checkpoints, or the numbers I'm going to use to check each interval to see if they're a solution or not. So, checking -1 first, right here, to see if everything less than 0 is a solution. That'd be 1 over 4 times -1 plus 5 over 8 times -1 is greater than 1/2. So, 1 over -4 is the same as -1/4 plus 5 over -8 is the same as -5/8 is greater than 1/2. I'm going to multiply the -1/4 by 2 over 2, and I'm going to get -2 over 8 plus -5 over 8. Really doesn't matter. You get -7 over 8. Is a negative number greater than positive 1/2? No. So this is false. So this area right here, or this interval, is not going to be a solution. I'll try plugging in 1 now. I'm going to have 1 over 4 times 1 plus 5 over 8 times 1 is greater than, not greater than or equal to, just greater than 1/2. So 1/4 plus 5/8 is greater than 1/2. Well, 5/8 is already greater than 1/2, so I can find a common denominator. That's going to be 2/8 plus 5/8. That's basically 7/8, and that's definitely greater than 1/2. So this is true. All my solutions are in between 0 and 1.78. Now it can't equal 0, so I'm going to circle the 0. It's just a greater than symbol, so I'm just going to circle the 1.75, and all my answers are less than 1.75 but greater than 0. I guess the way I'd write my answer for this is going to be 0 and 1.75. A is everything in between, so it's less than 1.75. And 0 is less than A, but we'd write it like that. So it's kind of like an AND statement for a compound inequality. 2 will not be a solution, but I'm going to plug it in there anyway, just to show you that it shouldn't be a solution. Well, I could use a checkpoint of 3 or 2, but I'm just going to use 2. So it's 1 over 4 times 2 plus 5 over 8 times 2 is greater than 1/2. So that's 1/8 plus 5/16 is greater than 1/2. 1/8 is multiplying by 2 over 2 is 2/16 plus 5/16 is greater than 1/2. That's 7/16 is greater than 1/2. Well, it's not. Over here you'd have 1/2 is the same as 8/16. That's definitely greater than 7/16. So this is false. And this would be our answer right here. Okay, here's our next one. A little bit more complex. We're going to solve this first, but second step is to find the values of y. It would make it undefined. Well, there's only one variable y in the denominator. It's y minus 1. So the undefined values here would be just taking y minus 1, that denominator set it equals 0, y equals 1. So basically y cannot equal 1. We're going to use that on our number line down here in a minute. Now to solve this as an equation, my least common denominator, I'm going to need a y minus 1. This is 1 over 1, and then I have the 6 over here. So just the numbers are constants by itself, we're going to need a 6. And then y minus 1 also. So 6 times y minus 1 is going to be my least common denominator. So taking 1 over 1, I'm going to multiply it by, first of all, 6, and also a y minus 1 because it doesn't have either of the factors in my denominator. Plus 5 over y minus 1. We're going to have to multiply that by, I'm needing a 6 over 6. Just equals now. 7, 6, I'm going to have to multiply it by y minus 1. Okay. So multiplying and figuring this all, well, 1 times 6 is 6. 6 times y minus 1, because I will multiply the numerators. Using the distributive property here is 6y minus 6. Multiplying 5 and 6, I'm going to get 30. I'm not going to distribute here, I'm just going to say this is over. Sorry, I forgot the denominator over here. 6 over y minus 1 is equal to, using your distributive property here, it's 7y minus 7 all over 6 times y minus 1. Okay. So we have a common denominator all the way across. I can drop that out and just solve the numerator. I got a negative 6 and a positive 30, so that's going to give me 6y plus 24 equals 7y minus 7. And I would subtract 6y from both sides. 24 equals y minus 7. Adding 7 to both sides, I get 31 equals y. So y equals 31. So looking at my graph now, we already decided from up here, y cannot equal 1. So I'll put a 1 right here. Our solution from down below is y equals 31. I'll put 31 right here. So that splits my number line, where I'm going to find my solutions, into 3 different intervals. You got interval 1, interval 2, and interval 3. Interval 2 is everything between, right here, between 1 and 31. Interval 1 is everything less than 1. And interval 3 is everything greater than 31. So I need to pick some checkpoints in order to decide what my solution is going to be. So I guess for 1, I'm just going to go with 0. 0 would probably be the easiest thing to use. Greater than 1, I guess I'll just pick 2. And 31, I'd pick 32. Now we're going to plug these in and see if it makes the inequality true or false. The original inequality, right here, checking 0 first, is 1 plus 5 all over 0 minus 1 is less than or equal to 7/6. So this is 1 plus, 0 minus 1 is negative 1. 5 divided by negative 1 is negative 5. It's less than or equal to 7/6. 1 minus 5, 1 plus negative 5 is negative 4. That is a negative number. That's definitely less than 7/6, so this is true. So what does that mean? Here are some of my solutions. They're less than 1. And 1 cannot be a solution, so I can't say, I know it's less than or equal to, so you'd want to circle it and color it in, but we're just going to circle it because it cannot equal 1. So first part of my answer This interval 1 here is going to be y is less than 1. And then maybe it's 2 and 3, or just 3, or either one of them. So we got to use those checkpoints and test them out. The next one I'm going to check out here. Get rid of this. Is 2. Plugging 2 in. Oh, I forgot my equation here again. So it's going to be 1 plus 5 all over 2 minus 1. Is that less than or equal to 7/6? So this is 1 plus 2 minus 1 is 1, so this is 1 plus 5 is less than or equal to 7/6 is about 1 and 1/6. So a little less than 2. 6 is less than or equal to 1 and 1/6. This is not true. This is false. So interval 2 between 1 and 31 is not a solution. I'm guessing that this is going to be a solution. And it's going to be an or statement. It's going to be y is less than 1 or y is greater than or equal to 31. But we still have to check it. So let's check it out here. Erasing this and plugging in 32. So 1 plus 5 all over 32 minus 1 is less than or equal to 7/6. So this is 1 plus 5 over 32 minus, that is 31. Okay, is this less than or equal to 7/6? Okay, I need a common denominator of 31. This is 1 over 1. I'm just going to multiply top and bottom by 31, so I can kind of add them together. So this is 31 over 31 plus 5 over 31. This is basically 36 over 31. Is that less than or equal to 7/6? I just used a calculator and divided. What did I get? I got 1.161 over here is less than or equal to 1.166. So it's extremely close, but this is the smaller number. So it is true. So now this is less than or equal to up here. So I'm going to circle this and color it in, because 31 could also be a solution. So y is less than 1 or y is greater than or equal to 31. Those are my, well, it's a compound inequality basically. Y is less than 1 or y is greater than or equal to 31. That would be my answer. That's the opposite of what the other two answers have been. Those have been more of an and statement type inequality, compound inequality. Last one. Here we go. So we'll get the number line down here. We'll get to that in a minute. I'm going to solve this as an equation. That's step 1. Step 2 is to find out any undefined values. Well, it doesn't matter. You can take 3x and set it equal to 0, or 5x and set it equal to 0. If you divide by 3 and you divide by 5, you're still going to get this. X equals 0. Or basically, it cannot equal 0. That's a constraint. So we're going to use that with the number line to find some of our answers here in a minute. So x equals 0 would be undefined. My undefined value. So I can't use that. So it helps us decide what our answer is on the number line. Now going ahead and solving this, I need a least common denominator. I need a 3 and a 5 and a 15. Well, 3 times 5 is 15. They both go into 15. So my least common denominator, I'm going to need a 15. And then there's 1x here and 1x here. I'm going to need a 15x as my least common denominator. So 1 over 3x. I'm going to have to multiply that by, I need a 15, so I'm going to have to multiply by 5 over 5. Minus 2 over 5x. I need 15x, so I need to multiply this one by 3 over 3. We'll just say is equal to 1 over 15. I'm going to have to multiply this one by x over x to get the x value in my least common denominator. So my new equation, or inequality, whatever, 5 over 15x minus 6 over 15x is equal to x over 15x. So, canceling out my denominators, I get 5 minus 6 is -1. So x equals -1. That's the answer I get from solving the equation part of it. And 0 is what I get from finding constraints. So if I break this up, now I'm going to put 0 over here and -1 over here. I break it up into, once again, 3 different intervals. It's probably going to be between -1 and 0, or it's going to be the 2 outside intervals over here where it'd be x is less than -1, and over here where x is greater than 0. If it's not those two, it's probably going to be between -1 and 0. X is in the middle. This would be my answer. Well, I don't know. I got to find some test points to check each interval. I guess for the first interval, I check -2. Between -1 and 0, I'd probably go with -0.5 or -1/2. And here I'd probably just check 1. Plug in 1. So I'll start with that -2 and plug it in to our original equation. So I'm going to get 1 over 3 times -2 minus 2 over 5 times -2 is less than or equal to, just less than 1/15. Okay, so that's 1 over -6, that's -1/6 basically. Minus, that's 2 over 10, -10. So I'll say -2 over 10. And this would be plus a positive. Least common denominators, probably for all of them, would be, well, 30 would be the easiest thing to do to check this answer out. So I'm going to multiply here by 5 over 5, 3 over 3, and 2 over 2 to check my answer. That's -5 over 30, because we did the plus a positive here. That's going to be plus 6 over 30 is less than 2 over 30. -5 plus 6 is 1 over 30. Is that less than 2 over 30? And it is true. Yeah, it is true. So I know this. I have solutions here. Now my answer can be -1, but it is just a less than symbol, so I'm just going to circle this. So I know this is part of my answer. I need to find out if these two are also part of my answer. So, let's see if I can use this over again. Three times, I'm going to try -0.5. And then we got 5 times -0.5. Okay. And we are subtracting. Yes. We are subtracting. So what do we got here? 1 over -1.5 minus 2 all over -2.5, must be plus a positive then, is less than 1/15. And I just changed it all to decimals. I changed this to a decimal and I added it to this as a decimal. I got positive 0.13 repeating. Is that less than 1/15? 1/15 was 0.06 repeating. This is positive, and 0.13 is bigger than 0.06, so this is false. This is false. So this area right here is not a solution. I'm guessing if we plug in 1 that it'll work out, but just to make sure, I'm going to plug it in. So we're going to use 1. So 1 over 3 times 1 minus 2 over 5 times 1, is that less than 1/15? So it's 1/3 minus 2/5. Is that less than 1/15? I get a common denominator of 15. So I'm going to multiply this by 5 over 5. Multiply this by 3 over 3. And I end up with 5/15 minus 6/15. Is that less than 1/15? I'm going to get negative 1/15, and that is definitely less than a positive 1/15. So this point was true. So I have these answers here also. It is less than, so I'm just going to circle it. It is less than over here, not less than or equal to. So I'm just going to circle it. So this is also part of my answer. So how do I write my final answer here? Well, for this particular inequality, there's 2 parts to it. X is less than -1 or X is greater than 0. Well, there you go, kiddos. That's solving inequalities. I know it's not the easiest thing in the world. If you do have questions with it, circle them or put a little question mark by it in your notes and come see me, and I'll help you out tomorrow.